This video is on Newton's second law by Morgan Handschuh and Adrian Sanchez. Newton's second law states that the acceleration of an object is directly proportional to the magnitude of the net force and inversely proportional to the mass of the object. As mass increases, acceleration decreases, and as force increases, acceleration increases. The equations we will be using for this are force equals mass times acceleration, and final velocity equals initial velocity plus acceleration multiplied by time. Say Adrian is pushing a shopping cart through a CVS. He is exerting force upon the shopping cart to make it move. The force he needs to push the shopping cart is less than what it would be if the cart had objects in it. The shopping cart is 28.18 kilograms. The initial velocity is 0 meters per second. The final velocity is 0.528 meters per second, and the time Adrian is pushing the cart is 9.21 seconds. Using the equation VF equals VI plus AT, the acceleration comes out to be 0.0573 meters per second squared. If Adrian adds water to the shopping cart, he will increase the mass of the cart. He adds 2 cases of water to the cart. Then, when he pushes the cart, he has to use a greater force to make the cart move at the same or greater acceleration. However, in this case, he actually doesn't make it move at a greater acceleration. The cases of water are 811.2 ounces, or 22.997 kilograms. The shopping cart is still 28.18 kilograms. The initial velocity is 0, the final velocity is 0.528 meters per second, and the time he is pushing the cart is 11.22 seconds. So, using the same equation, acceleration comes out to be 0.0471 meters per second squared. This means that initially, using the equation force equals mass times acceleration, the force comes out to be 1.61 newtons. After adding the cases of water, the force comes out to be 2.41 newtons. Notice how even though the acceleration has decreased, the force increases in the second case. This is because the mass has increased, and that is Newton's second law of motion in action.